Welcome to Art of Coding. In this video we are going to explore about enumerations in Swift programming language. An enumeration defines a common type for a group of related values and enables you to work with those values in a type-safe way within your code. C and Objective-C enumerations assign related names to a set of integer values. In Swift, you don't have to provide a value for each case of the enumeration. If a value is provided for each case, the values can be a string, character, or a value of an integer or a floating point number. How we can write the enumeration syntax? Let us see. Okay, this is the syntax of the enumeration. Here the north, south, east and west are the enumeration cases. You can use a case keyword to introduce new enumeration cases. Swift enumeration cases don't have an integer value set by default, unlike languages in Swift and Objective-C. In this example, the north, south, east and west don't implicitly equal to 0, 1, 2 and 3, but when we define it in C or Objective-C, they will have the values 0, 1, 2, 3. Instead, the different enumeration cases are values in their own right with an explicitly defined type compass point. Multiple cases can appear in a single line separated by commas. For example, instead we can just write the cases with a comma. Got it? Something like that. Each enumeration definition defines a new type, like any other types in Swift. Their names start with a capital letter and make sure to avoid the plural names. So how we can declare this as a type? Then var direction is equal to, so this enumeration now is a type. You can use compass point dot north. Here the this direction is inferred to a type of compass point. After that you can assign direction with a short dot syntax. Direction is equal to dot south. This is all about the how we can write enumeration and its syntax. You can match individual enumeration values with a switch statement. So here we can put a switch statement. Okay, so we can use the switch statement to enumerate the values in a switch statement. See, we got south. Some enumerations, it's helpful to have a collection of all of that enumeration cases. You can enable this by writing a case iterable after the enumeration name. For example, I am going to define a new enumeration. Beverages dot, or there is a property all cases. Okay, that will points all the cases in the enumeration. There's a count is there. You can check what the count. Will be 3. Okay, good. Next we are going to loop it for beverage in averages dot all cases. It will loop all the cases in the enumeration. This is a pretty easy way to get all the cases in an enumeration. The next we are going to check what is associated value in enumeration. So in this basic planned example, this enumeration shows how the cases of an enumeration are a defined value in their right. You can set a constant or variable to this planet case. For example, let and check for this value later. For example, we use the switch statement to check the planet. Okay, good. However, it is sometimes useful to be able to store values of other types alongside these values. This additional information is called an associated value, and it varies each time you use that case as a value in your code. You can define Shift enumerations to store associated values of any given type, and the value types can be different for each case. Let's take an example. Barcode. We have two cases. One case is UPC, then other one is QR code. Okay, so I'm going to define an associate value for each case. In this, it will having an tuple of four values, sorry, and QR code having a value of string. Okay, this can be read as define an enumeration type called barcode, which can take either a value of UPC with an associated value of tuple with 4 integer values, or value of QR code with an associated value of type string. How we can use this enumeration? It is create a variable is equal to barcode.upc. See, we have the associated values. We put some values 1, then we can also use the QR code dot QR code of string, some strings. Got it. This is how we can use the associated values. Barcode, in this case .upc, here got the values, so we need to get the values. For that, see this, we got all the values in the UPS, right from the QR code. We got the string. In this code we can do an updation, like if All of the associated values of an enumeration case are extracted as constants, or if all are extracted as variable, you can place a single let or variable annotation before the case name. For example, we can remove this L or the let and put up here let. Just remove this let. All good. So this is neat now. This is all about the associate values in enumeration. Enumeration cases can come pre-populated with default values, which all are of the same type. Have an enumeration. We declare the enumeration with of type character, so we need to put the value here. And carriage return. Okay, good. The row values can be a string, character, or any of the integer or floating point number values. When you are working with enumerations that store integer or string row values, you don't have to explicitly assign a row value for each case. When you don't, Swift automatically assigns the value for you. So take another example. So if this is integer, so Swift will automatically assign values. When it is character bond, we will get an error. Right. We need to explicitly assign values here. For string, let us say. For string also not problem. So the values will be the string or integer raw values. Let us take this integer and check what the values here. For iterating, how we can do that? We need to make it as case iterative, and for planet in planet node all cases, right? Then print planet growth row value. This is the method of getting the value of a case, the row value. So it starts from 0, but I want the value from 1. For that I put the first value to 1. So it will start from 1. If you define an enumeration with a raw value type, the enumeration automatically receives an initializer that takes a value of the raw values type and return either an enumeration case or nil. You can use this initializer to try to create a new instance of the enumeration. Let planet is equal to planet of, see this row value, Let us take it as 2. See what the value here. Print possible planet. It will be second one, that the Mercury. So it's optional. Unwrap it. Got a Mercury. So this is the initializer for the raw value type enumeration. Just take a higher value and there is no value, so it will get an error. Right. How to handle this? If let possible and okay, got it. Good. So this is about the raw values. Next is the recursive enumeration. A recursive enumeration is an enumeration that has another instance of the enumeration as the associated value of one or more of the enumeration cases. You indicate that an enumeration case is recursive by writing indirect before it. Also write the indirect before the beginning of the enumeration, like this. Good. Somebody is clean. So I'm going to do some arithmetic operations, for example addition and multiplication, like 5 plus 4 into 2. Okay, for this first number, that's 5. 5 is equal to arithmetic expression dot number, right? Number of 5. Then let 4 is equal to arithmetic expression number of 4. Then we are going to calculate sum. Let sum is equal to arithmetic expression dot addition of two expressions, that is 5 and 4. Then product equal to arithmetic expression dot multiplication. We need multiplication of the sum and 2. So we have the sum, it is number let 2 equal to expression dot number of 2. So here 2. So we can write an function that evaluates an arithmetic expression. Function evaluate expression of arithmetic expression. We are handling the int, so it will return an int value. Switch the expression and check for each cases. The first case is number, right? Number of value. Right, value then simply return that value. We don't have default case, we are going to put all the cases here. Case dot multiplication let right, then return left plus right. So we have the two arithmetic expressions. We also loop this function. For that, just call that evaluate of left plus evaluate of right. Got it. Here both are same constants. For that we can put let here, same way here. Sorry, plus, I guess multiplication right. Same way the multiplication. That's it. We can check how it will look. Evaluate. So we have to evaluate this product. What will the result? 5 plus 4 is 9 into 2, 18. The result will be 18. Good. So this is how we can declare and use the recursive enumerations. It will save a lot of time. And that's all about the enumerations. This is it. We will see you in the next video. Thank you.